Moving right along. This is question 21 in the first homework assignment, Chemistry 2A. And we've got diethyl ether, a substance, all right, blah, blah, blah. Diethyl ether has a specific heat of 0.895 calories per gram degree Celsius. Notice that this value is distinctly different from water's value of 1 calorie. So this one is a lower value. How many kilocalories of heat are needed to raise the temperature of 30 grams of diethyl ether from 10 to 30 degrees Celsius? Now, if you like equations, the equation we would have mentioned in class is to calculate the heat transfer sometimes. And, sometimes they say heat transfer, but heat in calories. The equation goes something like this. The mass of the substance, whether it's water or something else, in this case it is something else, mass in grams, times the so-called specific heat. Normally the symbol is C, but let me just, how should we do this? We'll just call it C. Okay, C is got the units of grams. No, I'm sorry, it's got the units of calories per gram degree Celsius. And with those complicated set of units, the gram on top here is going to eventually cancel the gram on the bottom here. And the last term we're looking for is delta T. The delta symbol means that we've got a change in the temperature, and delta always implies, and I mean always implies, that final temperature minus the initial temperature is what we're looking to plug into this spot. And that is, of course, in degrees Celsius as well. So the dimensional analysis, we didn't really need an equation because I promise you that the dimensional analysis is such that the gram on top here cancels the gram on the bottom. And even when we do a difference calculation with the temperature, it's still degrees Celsius as a result. And that cancels with the degrees Celsius here. We're left with calories. Okay, so let's finally set this particular question up. Heat in calories equals the mass. That's pretty straightforward. It's given to us in grams. And if it wasn't in grams, we'd have to convert from kilograms or whatever into grams. This specific heat is 0.895 calories. It's not 1.0 this time. And then finally, the change in temperature, which, like I said, it's the final temperature. I'm going to assume that there's a dot there just to make that 2 sig figs. Minus 10.0. I'm already suspicious of this value right here because whenever we don't, when you take a temperature, you got to be consistent about how many decimal places you go past the decimal point here. So this is 1 digit, and that's typical of most thermometers. This is a little suspect right here. I don't know what happened if the textbook actually, this is a textbook problem, if it actually did it this way or I just forgot to type a digit. So let's just assume that it was correct though. And when you do this difference calculation, which you have to do first, because the rules are different for sig figs, is we're going to say definitely the value is 20, but we're going to leave it as 20 and nothing else because there's no digits past the decimal point for this number. And the fact that there's 1 digit past the decimal point doesn't matter because this one restricts what we get, which is 20. And then we just multiply all these things together. And the fewest sig figs is 20. And so therefore our answer is going to have to be 2 sig figs. Okay, so let's do that on the calculator. I'm going to bring that up right now. We've got 30. I think I missed a digit here. 895, and then times 20. 537. So why is the answer set to 0.537? I'm a little confused here. Huh, that's strange. Did I misread this? Let me try this again because I'm not sure why I'm not getting that answer. Okay, 537. Okay, it looks like I have another answer set incorrectly, which is unfortunate. The answer is, with sig figs in mind, it's 5.4 times 10 to the second. That's calories. That makes a whole lot of sense. So it looks like the answer is incorrect at 0.537. I'm not sure why we're getting that value. because that is definitely incorrect. There's a lot more energy that's involved in this. So once again, when this homework assignment stops, I'm going to have to edit this response and fix that number because it is incorrect. And maybe, yeah, that's just got to get fixed later. This is the correct answer right here. And so put this one in. It'll probably say you're wrong, but it'll get fixed later for sure. All right, so that's it for question number 21. It's fairly straightforward. Just watch your sig figs when you do this difference calculation, but other than that, we're just multiplying the three numbers together. If you like equations, this one's given to you on the exam. You simply plug in the numbers. Be careful about the grams, though. Sometimes they sneak in a kilogram. You must convert it to grams first, but not in this case. Okay, 5.4 times 10 to the second calories.